PowerPro, a power management solution for data centers. As the cloud computing industry has matured over the past few years, energy is an increasing concern. Data centers are extremely energy intensive, and the default energy decision has historically been to keep all resources powered on, even if they are not fully utilized. In this era of cost cutting and sustainability, this is not the most efficient or optimal way to allocate resources. That being said, there is a lack of comprehensive industry solutions for power scheduling. While some products have looked at cooling or layout design and their impact on energy usage, scheduling in particular, which is the number of computers to turn on and off every period, has never been looked at. This is where PowerPro comes in. PowerPro enables service providers to experiment with various CPU power-up schedules in order to determine the optimal power policy that both minimizes cost while still maintaining service levels. After using our product, service providers will be able to reduce their power usage, minimize cost while still satisfying customer demand, and most importantly, accounting for turn-on penalties. It is not optimal to simply turn on and off CPUs in reaction to demand because there is a power penalty when you boot up a CPU, as well as a time delay which leads to a service loss. This is why we need a schedule. Some features of our product that make it attractive for the client are its experimental value and the ability to implement the results in an actual data center, sensitivity analysis, which is the ability to run multiple scenarios in order to see the effect on the objective. As mentioned before, it fills the industry niche and provides a service that has not been provided before. It captures data center complexities and intricacies and is a very flexible solution.
Now I'm going to walk you through a simplified version of our model. Customer demand is uniquely generated hourly based on the time of day. It differs between night and day, which is an accurate depiction to reality. Demand is then allocated to CPUs based on CPU availability and prioritized to CPUs which are already being utilized. The goal here is to maximize the number of idle CPUs. If there are not enough CPUs on and available in order to meet the current demand, then there is the option of turning on any additional CPUs. Once all the demand has been allocated, the job can start processing. At the end of the hour, the power cost is determined for that period. If our evaluation shows that there are idle CPUs, then there is the option to turn off some of them. Then, at the beginning of the next hour, demand is regenerated for each customer just as before.
And now I will walk you through our user-friendly interface. When the user first launches the simulator, they are greeted by the following screen. This gives the user a summary of the inputs required, as well as what plots and statistics our simulator will generate. From this page, the user clicks on Setup Experiment. Here, the user can alter the parameters of the model to their specific situation. When demand data is clicked, a series of forms are brought up which are used to modify input data. The forms have some built-in functionality to ensure that users don't accidentally enter incorrect values that don't make sense. For example, the maximum capacity must be between 0 and 1. If the user accidentally inputs a number not in this range, a message box pops up warning the user of the error and automatically sets the parameter to 1 in case the user attempts to ignore it. When the user has decided they are happy with their entries, they can click Save Basic Input to save the data to the model. Moving on to the Demand Variation tab, the user can decide what demand distribution best describes their daytime demand and nighttime demand. Clicking Change Demand Variation saves this. Finally, the user moves on to the Schedule tab. This controls the maximum amount of computers that can be turned off for each period. If the user is unsure about how to start off with entering values on the schedule, they can click Populate Schedule, which will automatically generate a schedule using the beta distribution which the user has already specified. When the user is satisfied, they can click Add Experiment to save the data. Now we are ready to run the model. We exit out of the form and click Run Simulation, which brings us to the Run Simulation page. If we wish to change the data we just entered, we can click Experiment, which brings us back to the previous page. If we are okay with the data, we will run the simulation. We do so by clicking Simulate. We are asked if we have filled in the relevant data. We have, and so we click Yes. We see that the simulation completed successfully, and click on OK to import the results. Everything has been imported. We see a menu pop up where we can return to the main page, exit, or view results of the simulation. We click on that. we are brought to the output page, where we can view summary statistics, cost breakdowns, and plots showing the number of computers turned on each period, as well as the number of idle computers each period. Using these results, we can return to the main page once again to run a different simulation with new parameters to see how it will affect our cost.
Now, to outline a few reasons as to why PowerPro differs from its competitors. PowerPro's product is scalable and customizable in order to meet the specific needs of each client. Also, as mentioned before, PowerPro offers a niche solution to power management, something which no other product offers. Additionally, our model captures complexities such as sharding, failures, and day and night demand cycles. Also, the outputs of our model can be easily implemented in a data center. Finally, and most importantly, our product supports industry-compliant metrics, essentially making the output user-friendly and understandable across the industry. With that, I would like to conclude our presentation. For further inquiries about our product or to learn about how our product can enhance your data center's power management needs, please feel free to contact our product team at powerpro@gmail.com. Thank you.